All right, so this video is picking up where the last left off in the sense that I'm going to show you how to get standard form quadratics. So ax squared plus bx plus c equals 0. How to get these from what their solutions are, right? So a lot of what we do in here is doing things forwards and backwards, right? So doing something and then doing the inverse. And that's exactly what I'm fixing to do in this video. So in the last video, we talked about how to solve quadratics using factoring. Now we're going to use those solutions to get factors and then get back to a standard form quadratic equation, right? So here we see, x1 is equal to 1/2, x2 is equal to -2. And what we can go ahead and do is look at them in pieces real fast. So let's go ahead and say I've got x equals 1/2. And I want to kind of go backwards, right? I want x to not be by itself. I want, to get something equal to 0. So I'm going to multiply both sides because I don't know about you, but I don't like fractions. I'm going to multiply both sides by 2. And then I'm going to just subtract 1. So now I've got 2x minus 1. Okay, so that's for this guy here. So now let's look and see, well, what's going to happen with this. So I'm going to go ahead and say x equals -2. And again, I'm trying to not get x by itself, right? I forgot to say that that's equal to 0. I'm going to try to get x not be by itself. So I'm going to add 2. Okay, so now I see I have two resulting equations, which just means what? Well, this standard form quadratic that I'm looking for comes from, if it has these two solutions, comes from this is a factor and this is a factor. In other words, I'm going to say one of the binomial factors of this unknown equation with these two solutions, one of the factors is 2x minus 1. The other factor is x plus 2. And we have that set equal to 0. And then to get it in actual standard form, ax squared plus bx plus c, all I need to do is FOIL. So 2x times x, 2x squared. 2x times 2, 4x. -1 times x, -x. -1 times 2, -2. Combine like terms, we get 2x squared plus 3x minus 2 is equal to 0. And there I have it. Ax squared plus bx plus c equals 0. I have my standard form quadratic resulting from those two solutions. All right, so let's do it again. So another example right here. Now we're saying x equals -3 and x equals -2/3. So starting on the left, real simple, add 3 to both sides, x plus 3. And now we have x plus 3 is 0, which means one of my binomial factors is going to be x plus 3. And over here, I'm going to multiply on both sides by 3 so that I don't have a fraction anymore. So 3x equals -2. Then add 2, 3x plus 2 equals 0. And I know the other binomial factor is going to be 3x plus 2. And we have that set equal to 0. Again, going back to the convention of standard form, right? Then we just FOIL to actually get that convention. So we have 3x squared plus 2x plus 9x plus 6. Combine terms, 3x squared plus 11x plus 6 equals 0. And we've got it. One last example just to make sure we've really got it. We see that we have x equals -8 and x equals 9. So on the left, it's just x plus 8. On the right, it's just x minus 9, which means my two binomials are x plus 8 multiplied by x minus 9. Those are my two factors of my standard form quadratic that have these two solutions. We're just going to FOIL. So x squared plus 8x minus 9x, so minus x minus 72. And we're done. Okay, so pretty straightforward. All I did was what I did in the previous video where I talked about factoring to solve quadratics to get solutions, right? I just did that backwards. This is going to arise in certain facets of standardized testing like the SAT. You will probably see stuff like this. So it's good to know. And just like anything else in mathematics, it's good to know how to do something backwards. Just as good to know how to do it backwards as it is forwards. So if you have any questions over this, shoot me an email. Otherwise, you know where to find me. Goodbye.